Hello and Assalamualaikum to Dr. Ashikin and all of my friends. So we are from Group 2, Section 7, are going to be presenting about our rock mass rating data that we obtained from our project trip in Mersing. So these are our team members. First one, we have Adlin Nurliana, and then me, Siti Hazira, Nur Elisha, Amin Said, and lastly, Nurul Yasmin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Yasmin Hamid and I will present our introduction and objective. So, engineering geology is a branch of civil engineering that studies the effect of geological materials and conditions at construction. So, it focuses on rocks, soil, and geological structures to ensure the safety and stability of projects like slopes, tunnels, and foundation. It's important in area with a complex or challenging geological condition, and our project is conducted in Mersing Johor and it covering 4 locations: Air Hitam, Teluk Iskandar, Curun Tanjung Resang, dan Pantai Pasir Lanun. So the activities includes rock and mineral identification, structural mapping, weathering classification, and scaline survey. So field tests such as Schmidt hammer were conducted and rock samples were collected for lab tests like point load, index, and slag durability. Slope stability was analyzed using RMR, SMR, and StereoNet-based kinematic analysis. This project helps students to improve geological assessment skills and prepare for real-world geotechnical works. Next is objective. So our first objective is to classify and characterize the rock types and geological structures found at 4 selected areas or sites in Mersing. And our second objective is to assess the geomechanical properties and quality of rock masses through field and laboratory tests, including RMR and SMR evaluations. And the third one is to analyze slope stability using StereoNet-based kinematic methods and determine the potential mode of failure and factor of safety for selected rock slopes.
Assalamu alaikum warahmatullah. My name is Amin Said Al-Taib, my matic number AF230098. Today I want to talk about our literature review for our project. Confirm that rock stability assessment rely on established rating system evaluating 6 key factors: rock strength, fracture density, joint spacing, joint surface quality, and groundwater and joint orientations. These generate a rock quality score to guide engineering decision. Belt methods like rebound hammer and digital fracture mapping provide critical data. While slope stability analysis predict collapse risk by comparing fracture patterns with slope angles. These approach are essential in geological complex area like Mersing, with its volcanic rocks, folded trials, and heavy weathering, where tailored solutions are needed to address unique stability challenge. Thank you.
So now I'm going to be presenting about the methodology that we used in this project. So the first one is site preparation. First, we have to choose a proper site that reflects the typical geological conditions such as slopes, tunnelways, and also spillways. And then we have to remove any excess soil, vegetation, and loose weathered rocks that are in the site. Then, a scan line was established across the section in order to identify and record joint discontinuities. Furthermore, groundwater condition was observed and also noted. This is because the presence of water can reduce rock strength and also affect slope stability. So the next one is uniaxial compressive strength. In short, we call it UCS. So what is UCS? UCS is a simple non-destructive testing device method by using a rebound hammer. So the UCS is to assess the rock quality by measuring the hardness of its surface through rebound values according to Basu and Aydin 2004. Furthermore, according to Zilagi et al. 2011, it is to determine the relationship between surface hardness and also compressive strength. Readings were taken at 9 different points and the average reading were counted. The third one is rock quality design. In short, we call it RQD. This is to characterize rock masses and as a measure of the quality of borehole core. According to Lucien and Wang Wei 2013, the success of RQD is when the ratio or percentage of intact core pieces are longer than 10 cm over the total drilling length. And according to Zhang 2016, the increase in joint spacing generally results in higher RQD values, indicating better rock quality. And RQD is one of the key parameters that is used in calculating and determining rock mass rating, RMR. So the last one is Clino application. What is Clino application? It is technically a digital compass and clinometer to measure the orientation of geological features by only using smartphones. Smart, right? It provides accurate readings of dip direction and also dip angle. And Clino indirectly make geological surveying faster, more accurate, and also more efficient.
So this is our result and calculation at site 1, air hitam. So the first step, we need to calculate number of joints using this formula, and we get our number of joint is JV equals to 11. Then we need to calculate our RQD using formula RQD equals to 115 minus 3.3, and the answer that or result that we will get for RQD is 78.7. Second step is to know rock quality designation, and the answer or the result that we get from our side is RQD equals to 49%. The third step is to know unit axial compressive strength UCS, and the average that we get is 47.8. Next is the table. It shows classification parameters and rating to know the condition of the rock. So after we know the strength of indirect rock, drill core quality RQD, condition and discontinuity and groundwater, so the rating and the total that we get is 57, and it shows the rock is poor. Next is site 2 Telok Iskandar. So Telok Iskandar, our activities is to know we need to know fault rock structures. So this is our table. We have 31 data. So this is it.
So for the site 3 at Cerun Tanjung Resang, here is the result and data, deep angle and deep direction that we obtained, and the calculation that we calculate is the first one, a number of joint per 1 meter cube. We got is GV equals to 26, then the RQD we obtained is 29. So the second, we calculate the rock quality design. The first one, we draw the rock that we choose. And then we calculate the RQD, which is we obtain the 38 plus 25 plus 20 per 100 multiplied to 100. We obtain is 83%. The third one, for the UCS, we obtain the average is 39.8 MPa. And the last one, we classification the parameter and the rating, which is the first one, strength of intact rock is 1 to 5 MPa and 25 to 50 MPa. The rating is 4. The drilling core quality RQD is 25% to 90%, and the rating is 17. The third one is spacing of discontinuity. The description is the value that we obtain is 60 to 20 mm. The rating is EEC. The condition of discontinuity is silicon-sided surface or couch, less than 5 mm thick, or separation 1 to 5 mm, and continuous. The rating is 10. The last one, the groundwater is completely dry, which is good, and the rating is 15. The total we obtain is 54, which is equal. So for the last site, which is at Pantai Pasir Lanut, for this site, we observe that the scale line of the rock, which is how many scale line that we obtained from one section, which is 2 meters, and by that we get the deep angle and deep direction. So here is the data that we ambil at that site.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alisha binti Zulkifli. Today I'm going to explain about discussion on site 1 at Air Hitam. First of all, we figure out the spacing varies from 0.5 until 1.5 meter. Then the RQD obtained from the value of S1, S2, S3 and S4 is 78.7%, which is high. Next, the rock mass rating RMR calculated was 57, which is classified as poor based on the table 1. This is mainly due to low intact rock strength 2 to 4 MPa. Lastly, the UCS test we measured using rebound hammer reached the average of 47.8 Newton per millimeter square, indicating considerable strength suitable for engineering applications. For the second site, at Teluk Iskandar, first of all, the discontinuity spacing ranges from 0.3 to 1.0 meters, but many measurements cluster below 0.8 meter, indicating closely spaced discontinuities that reduce overall rock mass competence. At this site, we see that metamorphic structures including foliation, folds, and faults within quartzite and phyllite outcrops. From this determination, we can see that how important is the structure, features and mineral composition influence rock behavior and contribute to strength and deformation of rocks. Such detailed structural analysis is very important for assessing slope stability, predicting failure modes such as planar and wedge failures, and designing appropriate engineering solutions.
So for the third site, which is at Cheren Tanjung Resang, the rock type is pyroclastic tuff, which is very weak. From the data we got at this site, is strength in range 1 to 2 MPa. With the score we got is 4. RCD value is 83%, with score is 17. Spacing of discontinuity is from 16 to 20 mm, and score is 8. Condition of discontinuity is silicon-sided. Thin gauge is 1 to 5 mm, and continuous, which is we obtained this rating is 10. The last one is rock was completely dry, which is good for slope stability, and the rating is 15. So from the sum of the rating above or score, we obtain the RMR value is 54, which is equal due to its low strength and weak joint condition.
So for the last site, at Pantai Pasir Lanut, the main geological observe that focus on the pyroclastic rock formation, which is that form from volcanic eruption consisting of the mix of ash, pumice, and fragmented volcanic material. Second, we assess the rock mass stability using scale line survey in 2 meter. Joint spacing of discontinuities is closer, which is means weaker zone in the rock mass. From this, we can see the figure, the scale line that we obtained. So for for the first picture, we take the 3 section of that from this side. The first section we obtain the S1 is 8, S2 is 3. So for the second section we obtain that S1 is 1, 2, 3, 4, 5, 6, 7, and the S4 is 2. For the figure 3, section 3, we obtain that we have 3 scale line, which is the first one we obtain that 1, 2, 3, 4, 5, 6, 7, 8. The S2 we obtain that 2, 4, 6, and the last scale line we obtain is 4. So we know that the joint spacing is closer, so that, and which means it weaker zone for stability of this rock.
So in conclusion, Site 1 in Air Hitam showed moderately strong rock with relatively good RQD values but poor overall rock mass quality due to weak joint conditions and also low rock strength. While Site 2 in Teluk Iskandar exhibits significant structural complexity with tightly spaced discontinuities and folded metamorphic structures, indicating potential instability and the need for careful structural analysis. Furthermore, at Site 3, which is in Cherun Tanjung Resang, although the RQD value was fairly good, the rock mass was classified as poor due to very low intact rock strength and unfavorable joint characteristic. Lastly, Site 4 in Pantai Pasir Lanut consists of pyroclastic rocks with highly variable joint spacing, highlighting zones of structural weaknesses that could pose risk for engineering work. Overall, the project emphasizes the importance of combining field observations, structural mapping, and rock mass classification systems such as rock mass rating and also rock quality design to thoroughly assess the geomechanical characteristics of rock masses. Through this project, students gain valuable hands-on experience in geological fieldwork and also data interpretation. By analyzing different rock types and discontinuity patterns, the project successfully bridged between theoretical knowledge and also practical skills for future engineering practices.